And welcome everyone to the YouTube channel of Infinity Learn by Sri Chaitanya, and today we are going to start Parallel Axis Theorem. I am Ravindram and I will be taking this topic today. So let's move ahead. So let's begin with Parallel Axis Theorem today, students. It's a topic of moment of inertia, right? We all have studied moment of inertia. We already know what's moment of inertia now, but we were restricted when we were studying moment of inertia in the very beginning because we didn't had many tools to find out moment of inertia of different bodies about different kinds of axes, right? So these different theorems, this parallel axis theorem and the perpendicular axis theorem, what does it do? They equip us so that we can solve different problems of finding moment of inertia for different kind of bodies about different types of axes, okay? So it's kind of gives us more accessibility towards the topic, right? Now, so let's begin with Paralyxis theorem. It is one of the very important topic, and why I am saying very important, because whenever a question comes from moment of inertia, there's a high possibility that it will be solved using the concept of Paralyxis theorem or perpendicular axis theorem, right? So let's pay attention and start studying this particular topic. So first of all, I would like to tell you that this is applicable in all the three-dimensional objects. That means it's applicable for linear objects, for planar objects, and as well as for three-dimensional objects. Now here, first of all I will tell you what does this theorem say, right? What does this tells us? Then we will go into the derivation and like proof of this theorem, and then we will apply this theorem in different linear objects, in planar objects, and in three-dimensional objects. And one more thing we will be studying in this lectures, that is the reverse of the Paralyxis theorem, right? So we'll be studying all these things, covering all these things in this particular lecture. So stay tight, okay, stay tuned and sit tight. So let's move ahead now. Okay, so what is given? For example, I have a body, I have a rigid body like this, and I want to find out the moment of inertia about this axis. That means I want to find out moment of inertia about this axis. This is my target. Now what I should do? So there's a very simply, I have one method. One method is very simple, that is what? R square dm integration. That we can obviously do always, but this theorem will help us to solve this particular concept very easily. How? What we will do? We will draw a parallel axis to this AB. So we will draw a parallel axis to axis AB such that our parallel axis will pass through center of mass, okay? So this will be our parallel axis, okay, which will pass through the center of mass of this particular rigid body, right? And then we will measure the perpendicular distance between these two axes, that is coming out to be D. Sometimes we write it as D, or sometimes we can write it as X or A, whatever, it doesn't matter. But remember that this is the perpendicular distance between these two axes, AB, about which we need to figure out the moment of inertia, and this is what the axis passing through center of mass and parallel to this axis, right? So these two conditions are necessary. That's first condition, that this axis should be parallel to our axis AB, about which we need to figure out moment of inertia, plus this axis should definitely pass to the center of mass of that rigid body. So once these two conditions are met, then we can apply this formula. Can you see this formula? IAB is equals to I about COM, parallel axis, right? Parallel axis, I about COM plus MD square. D is the perpendicular distance between both the axes. So we can directly apply this concept and get the answer. Here I have mentioned what is the meaning of IAB, ICM. M is the total mass, D is the perpendicular distance between the axes AB, about which we need to figure out the moment of inertia, right? I hope you have understood this thing. Okay, so this is what? This is Paralyxis theorem. So clear? Again I will write it down. I about any axis you want is equals to I about center of mass. That means you need to figure out I about the center of mass, which axis? An axis parallel to axis AB passing through center of mass. About that particular axis we need to know moment of inertia plus m times square of the perpendicular distance between the two axes, right? So this is the formula that we will apply in parallel axis theorem, right? Now let's get the proof of it. Okay, the proof is quite easy. Simply we will say that let's say this is any rigid body, and like this is the axis AB, about which we need to figure out the moment of inertia, right? So let's figure out where is center of momentum, center of mass. So you will say, sir, this is center of mass. Okay, let's figure out this is center of mass, and draw an axis parallel to axis AB passing through center of mass, and let's say this is Okay, let's say moment of inertia about this is ICOM, moment of inertia about this will be IAB, right? Now, what we need to figure out is, we need to figure out what is the moment of inertia of this body about AB, axis AB. So, what we will do, simple concept, let's say, let's take an object here, a very small object, which is, whose mass is dm, right? And we will say that center of mass is at origin, okay? So, we will consider center of mass to be at origin, and from this we will measure this distance as r, okay? And we already know that this distance is, let's say, a, okay? This distance is a. A is a perpendicular distance between the axis about which we need to figure out the moment of inertia and the axis of passing through the center of mass, parallel axis passing through center of mass. So, this particular information we have, right? Now, let's say that this whole distance is what? This is x, right? So, if I want to find out moment of inertia about AB, small moment of inertia about AB, because we have taken small element, that will become how much? It will become x square dm, right? Integration. I have just called this total distance x. Now, what is x? You will say, sir, it is, how much it is? It is a plus r whole square dm integration, okay? Right? Are you able to understand? So, what is the integration of this? You will say, sir, IAB, right? So, from here we will say I about axis AB will become a square plus r square plus 2ar dm integration, right? Now, we will say I about AB will become a square dm, you are going right, in the right direction, right? R square dm, perfectly right direction, plus 2ar dm, again a perfectly right direction, right? Now, what we will do, I will say that I about AB will become, see, a square is a constant, you can keep it outside and just integrate dm. Now, we all know that if we integrate dm, that means small dm elements of this complete object, after integration will become capital M, right? Plus r square dm. Now, what is r square dm? Just tell me. R is the distance from the axis which is passing through center of mass, right? This axis, okay? So, r square dm integration will definitely give me ICOM, don't you think so? This is nothing but ICOM I am getting here, moment of inertia of this complete body about center of mass axis, about an axis passing through center of mass, right? Plus here 2 and a are constant, I will bring it outside, and integration of r dm. Do you understand? Integration of r dm. Now, this is pretty interesting, okay? See, integration of r dm, you must have seen it somewhere, okay? If you remember, for a uniform body, if you were asked to find out center of mass, you used this formula. Yes or no? This used to be the coordinate of center of mass. This is how we used to find out the center of mass in a uniform body, right? Now, here you tell me, since I have taken the distances, I have measured the distances from center of mass, that means I have pretty much assumed that the center of mass of the body is at origin, right? So, if it is at origin, that means this quantity will be 0. So, r dm integration will be 0. Do you understand? So, technically this is equation number 1 that we can use it here, okay? So, we will say that IAB is equals to a square into m plus ICOM plus 0. So, after rearranging we will get this equation that IAB is equals to I about COM Do you understand this thing? So, this is the final proof or derivation of parallel axis theorem that we have it right here, okay? So, I about this axis AB will be equal to what? I about center of mass, I about an axis passing through center of mass parallel to AB plus m times per square of the distance between these two axes, right? Okay, I hope it is clear now, fine. So, let us move ahead, this derivation is understood by you. Now, let us do a question. Now, we will take simple questions, then we will do some good questions at the end, okay. Now find the moment of inertia of a rod. Okay, so let's take first linear object. Okay, this is a rod. Find the moment of inertia of a rod of mass m. Okay, mass m is given, length L is given, about an axis passing through it at a distance L by 4 from the central axis of rod. So this is the central axis of the rod. Okay, so they are saying that there is an axis which is passing at what distance? L by 4 from the central axis, and this is also, we all know that this is center of mass also. So this is your axis AB about which we need to figure out the moment of inertia. So can you apply this concept here? You will say simply, we will draw an axis parallel through AB passing through center of mass. This is that axis, we already know this. Okay, so it will become ICOM plus m into a square, distance, perpendicular distance between the axis, that is also given L by 4 in the question itself. So you will say, sir, IAB will become, ICOM is how much? M L square by 12. What do you say? M L square by 12 about this axis, plus you will say, sir, m into L by 4 whole square. It will become L square by 16, right? So it will become ml square by 12 plus ml square by 16. So 12 4s are 16, 3s are is how much? 48 only. So denominator will be 48, 12 4s are 48, 12, 16 3s are 48. Okay. So we will say IAB, this is the value. How much is this? It is 7 ml square by 48, I suppose. Is it clear? Is it clear? Any doubt in this, please let me know, students. Okay. So this is a very simple concept. We just found out how to find out the moment of inertia, because otherwise what would you have done? You would have started integrating it. Okay, from minus L by 4 to plus 3L by 4, like that. You would have integrated and solved it. Instead of doing that, don't you think it's a wonderful method we have right now? Because about this central axis, we already know the moment of inertia. So usually what happens when we apply parallel axis theorem, we use it in such a way so that we know this moment of inertia already. Then only this perpendicular axis, this parallel axis theorem will become easy to apply. Otherwise, if we don't know this also, we neither know this, nor we know this. So what will happen? Then it will become a headache to apply this equation. Otherwise, we can directly integrate and get the value of IAB. Are you understanding? So we apply this theorem only when we know the moment of inertia about an axis passing through center of mass and parallel to AB. If we know that thing already, then only we can apply this concept and get the answer quickly. Otherwise, this method will also be a little difficult or time consuming method. Now find the moment of inertia of a hollow cylinder. Fantastic. M and radius r about an axis perpendicular to its circular face, okay, its face, and tangent to its curved face. So it's pretty easy. First of all, we will see this is a cylinder. What kind of cylinder they are asking? They are asking for a hollow cylinder, right? Okay, fantastic. What is the axis they are telling us? They are saying that this is the axis, right? It is touching the curved face and perpendicular to the circular face. Right, do we know? Now where is the center of mass? This will be the center of mass of the system. So we need an axis which passes through center of mass and parallel to the axis AB that we need to find out the moment of inertia about. So definitely we will take an axis which will pass through center of mass. Now this is the central axis, and I suppose everybody knows what is the moment of inertia about this. Okay. So what is IAB? IAB will be ICOM plus MA square. Now you tell me what is the perpendicular distance between these two axes. You will say, sir, R, that is the radius of the cylinder. So IAB will technically become MR square. This we all already know, okay. Moment of inertia of a ring about its central axis or a hollow cylinder is same, that is MR square only, right? We know this already. Plus we will say M into what is A, it is equals to R only. So don't you think answer will become, IAB will become 2mr square. Okay, so this is your answer, students. Do you get this? Isn't it easy? So now in a three-dimensional object we have applied this concept now, right? It's very easy, no need to worry, just apply the concept very carefully and get the answer, right? Now find the moment of inertia of a uniform sphere of mass m, okay, of mass m and radius r about a tangent, okay, if the spheres are solid and hollow. Okay, so once let's take a solid sphere. So say this is a solid sphere, right, this is a solid sphere, and what they are asking is moment of inertia about which axis? About this tangential axis, right. So this is A, this is B. Again what we need to do, first of all find out center of mass. I suppose this is the center of mass. Then draw an axis parallel to this axis passing through center of mass. This becomes the diametrical axis of solid sphere. We are talking about solid sphere, right. Now what is the distance between them? You tell me. You will say, sir, A is equals to capital R, right. Now do you know any moment of inertia about this axis? Do you know this thing? You will say, yes sir, it is 2 by 5 mr square, right. So what is the moment of inertia about AB? You will say, sir, ICOM plus MA square. So here in this particular case it will become 2 by 5 mr square plus mr square. I suppose it will become 7 by 5 mr square. So guys, you understood this thing? All of you, I hope you are understanding this concept, right. This is very simple. Now for a hollow solid sphere also we can solve it. Hollow sphere is also very easy. Just in place of 2 by 5 mr square you do 2 by 3 mr square, that's all, nothing else. Okay, so when you take a hollow sphere, what will happen here? Hollow sphere is this. Okay, so this is a hollow sphere. Now again you will say this is the tangential axis, right, about which we need to find out the moment of inertia. This is A, this is B. So I about AB again will be what? I about center of mass plus MA square. Now search for center of mass. This is the center of mass. Draw the axis passing through center of mass. Absolutely. What is the perpendicular distance between them? You will say, sir, R. So what is gonna be AB? You will say, sir, AB will be 2 by 3 mr square plus mr square will become how much? 5 by 3 mr square. So this is something very easy. Now this has made our job so easy, otherwise it would have been so difficult now to integrate from this particular axis and get the value of moment of inertia. So don't you think it has become so easy for us, right? So Paralyxis theorem makes our job a lot less painful, okay. Now let's do this question. Find the moment of inertia of a uniform square plate, of mass capital M, right. Edge length is given L, okay, fine, about its axis passing through P and perpendicular to it. Okay, so you can see this axis. So it's like this, okay, the axis is like this. So we all know that first of all I about this axis P will be equal to I about center of mass plus MA square. Again we will apply this concept, no problem. Now you tell me, where is the center of mass? You will say, sir, this is center of mass. So we should have one more axis parallel to axis P passing through center of mass like this. Can you see that these two axes are parallel to each other? Now what is the perpendicular distance between these two axes? You will say, sir, this is the distance. So this is half of the diagonal, can't you? Can you see that? So this is A, and if I say A is nothing but half of the diagonal, what is the diagonal? Root 2L, right? What is the diagonal? Root 2L. So A will become L by root 2. It's very easy. Now you will say I about axis P will be, now what is I about center of mass? Tell me. I about center of mass for a square lamina is m by 12 into L square plus L square. Okay. So it is what? ml square by 6. We already know that. ml square by 6. Now we will put this value here and say ml square by 6 plus m into L by root 2 whole square, that is ml square by 2, right. So it will become ml square by 6 plus ml square by 2, 3 plus 1, 4. So it will become 2 ml square by 3. I suppose this is the right answer. Okay, so I hope you are understanding and you are getting the feel of this particular concept. Okay, is it clear? Just let me know. Okay, let me know. Okay, in the chat options also, in the comment options also, students, you can let me know whatever doubts you are having regarding this topic. Okay, I will try to answer it there itself. Okay, now let's move on to one more question. Find out this is a good question. Now this is the good question. This is the question of the video. Okay, find out the moment of inertia of a semicircular disc. Now let's try to understand. This is a semicircular disc. Can you see that? About an axis passing through its center of mass. So where is the center of mass? Here. Okay, and perpendicular to its plane. Fine. That means we need to find out the moment of inertia about this axis. Okay, so this here what we will do, we will apply a concept of reverse perpendicular theorem. Okay, sorry, reverse parallel axis theorem. Reverse parallel axis theorem. What we will do? We will do it like this. See, we know that I about any axis AB is equals to I about COM plus MA square, right? So we can also say I about COM is nothing but I about that axis AB minus MA square. Now this is the reverse of the parallel axis theorem. So we generally used to know the value of ICOM and we used to find out the value of IAB, right? Now here the opposite we are doing. We need to know the moment of inertia about an axis AB, and through that, using this concept, we need to figure out the moment of inertia about the center of mass of this particular body, right? So this is a disc they have already given us. Okay, fine, fantastic. So this is a disc, as you all can see it, right? Now about which axis you already know the moment of inertia? You will say, sir, about this axis we already know. One thing we all know that if this is a disc, okay, and you want to find out the moment of inertia about this axis, for a disc I am saying, obviously moment of inertia will remain mr square by 2. Okay. Now even if you take a semicircular disc, right, and you try to find out the moment of inertia about this axis, same mass m radius r, again moment of inertia will not change. Why? Because the distribution of the mass about the axis is not changing, it's still the same. We will be discussing this in the coming lectures. So let's write down, it will remain same. So moment of inertia will not change. Why it will not change? Because the distribution of the mass is still, see, if this is the axis and if I talk about this axis, if I divide this, the way mass is distributed on the right hand side of the disc, similarly the mass is distributed in the same fashion, and in the same amount. So these two things are important. In the same fashion and in the same amount, mass is distributed on the left hand side also, right? Are you understanding? That means if I say moment of inertia for the complete disc is mr square by 2, and if I take only half of the disc of the same mass, since the fashion and the amount of mass on one side of the axis is not changing, we can say yes, the moment of inertia will remain same, right? Because in the very beginning, if you remember, moment of inertia is something depends upon two things. Number one is the axis that you choose. Number two, how the mass is distributed around that axis. If the distribution of the mass around the axis is not changing, so even though you remove this particular portion, moment of inertia will remain same. Though I have taken, so I am not cutting it half, I am just taking another semicircular disc of same mass and radius, right? So let's come back to our question. So this is ICOM. How much will this be? You tell me. Sorry. This will be equal to mr square by 2. Now what is the perpendicular distance? This you must remember. This was 4r by 3 pi. Do you remember this thing? This is the height of center of mass in a semicircular disc. Now you will apply this concept and say I about COM will be nothing but mr square by 2 minus m into 4r by 3 pi whole square. Now after solving this, you might get the right answer. Okay, so do you understand this concept now? This is a wonderful concept. Here with the help of what? With the help of reverse parallel axis theorem, we found the answer about the center of mass. Okay, moment of inertia about center of mass. Now one last question of this video. So let me wind it up this video with a very nice question here. Find the moment of inertia of two uniform joint rods. Okay, of mass small m and each. Mass small m and each about point P as shown in the figure using parallel axis theorem. So they have already mentioned that we have to use parallel axis theorem. Now what we are going to do, now since there are two masses, okay, one is this rod, another is this rod. So what we will do, we will deal with them individually. So first we will deal with this rod already. So let's say I1. So I1 everybody knows is ml square by 3. I don't need to discuss anything on this, right? We already know the moment of inertia of this particular rod, okay? What I am talking about? I am talking about this rod. About which axis I am talking about? I am talking about this axis. Everybody knows how it's going to rotate. It's going to rotate like this. So what is the moment of inertia? You will say, sir, ml square by 3. So there is no dispute or no doubt over this, right? So I1 I can say is ml square by 3, right? This is number one, point number one. Now let's talk about this particular rod. Where is this rod kept? This rod is kept here like this. And where is our axis? Our axis is here, right? Now what we will do, we will find out the center of mass first of all of the object that we have, mass m, length l, right? Now this is the center of mass. Now we will draw an axis which is parallel to this axis and passing through center of mass. That is what parallel axis theorem means, right? So we will draw another axis passing through the center of mass of the body and parallel to this axis. Are you getting my point? Yes. Now what is the distance between them? This is the distance between them, a, right? Now you tell me, what is this? You will say, sir, this is L by 2. What is this? You will say, sir, this is L. So according to Pythagoras theorem, you will say, sir, a square is nothing but L square plus L by 2 whole square, and a square is nothing but L square plus L square by 4. So a square becomes 5L square by 4. I hope you are understanding this, right? Now what is I2? I2 will be ICOM, please apply it carefully, plus MA square. Now what is the moment of inertia of this rod about its own central axis? ML square by 12, right? So you will say, sir, it will be ML square by 12 plus 5ml square by 4. Do you understand this thing? Right? Why? Because a square is 5l square by 4, right? So we will say now this 4 3s are 12, 5 3s are 15, 4 3s are 12, 5 3s are 15 plus 1 16. So it will be 16 ml square by 12, that is 4 by 3 ml square. This is I2, okay? Now what we will do, we will need to find out, we have to find out the final answer also. Now you tell me what will be the final answer. Final answer will be I1 plus I1 plus I2 will be the final answer, I. Now what is I? Tell me, I1 is how much? I1 is ml square by 3, ml square by 3 plus what is this? 4 ml square by 3. It is 4 ml square by 3. So finally your answer will become 5 ml square by 3. I hope this is how you get the right answer. So in this half an hour I have tried to explain you complete moment of inertia, parallel axis theorem, okay, with some good questions in it, right? See, there is no end to questions. You might say, sir, you have not discussed that particular thing, that particular question. See, these questions doesn't have any end, right? But I have tried to cover the concept and its application in this half an hour, and I hope you understand it, like it, okay? So that's all for today. Thank you, students. Please subscribe to our channel and keep learning infinitely, right? That's all for today. Thank you. Tada, bye bye.